In the Amazon Web Services Cloud, a virtual private cloud or a VPC is really just a virtual network definition that you've created in AWS. It's quite similar to what you might do on premises if you were responsible for establishing a new network or a new VLAN, a new subnet, whatever the case might be. You have to think about why you need that new network in the first place and the addressing that goes along with it. Now, in Amazon Web Services, the VPC can be allocated an IPv4 CIDR block. CIDR, CIDR, stands for Classless Interdomain Routing. It's a method of specifying the bits in a subnet mask with the slash notation, such as /24 if there are 24 bits in the subnet mask. In decimal, that would equate to 255.255.255.0. But you can also allocate IPv6 CIDR blocks to a VPC. Pictured on the screen, we have a screenshot of creating a VPC. At the top, the default selection is to create the VPC resource only, or you can opt for VPC and more to create additional items such as VPC subnets all at the same time. You can specify the name tag value to give a name to it to facilitate working with it, such as in the AWS Management Console. And you can specify your IPv4 CIDR block, your range of IP addresses, by manually inputting it, or if you've created an IPAM allocated block pool, then you could select that from the list if you've set that up ahead of time. IPAM standing for IP Address Management. Down below, you can also at the same time specify an IPv6 CIDR block for your VPC. It can, once again, be IPAM allocated if you've already set that up ahead of time. It could be Amazon provided, or you might already have an IPv6 CIDR that you own. So to have a truly functional virtual network configuration in the Amazon Web Services Cloud, you would also have subnet resources created. A subnet belongs to a VPC, and its IP address range is derived from within the VPC's IP address range, be it IPv6 or IPv4. You can also configure DHCP options for your VPC. You might do this, for instance, if you wanted to customize some DNS settings. You can configure a network ACL, an access control list for subnets, which is kind of like having a layer 4 packet filtering firewall. Network ACLs consist of rules that either allow or deny network traffic coming into the subnet or leaving the subnet. So naturally, when you launch a new EC2 instance in a subnet, it uses the network ACL rules for that subnet. You might also have a route table if you need to control network traffic flow. And of course, like creating any resource in AWS, you can assign up to 50 tags, in other words, key and value pairs, as metadata for your VPC or your subnet or your route table, all of those items. In our screenshot, we have the VPC Management Console. You can just search for VPC in the Amazon AWS Management Console to get to this screen. On the left in the navigator, what's been selected is subnets. And so we have a list of all of the subnets along with their IPv4 CIDR ranges in our particular case. Under the IPv6 CIDR column, we have nothing simply because it's not been configured for those subnets. Notice that the subnets also are associated with the VPC shown under the VPC column. VPCs can be created and managed over on the left in the navigator by clicking Your VPCs. But also notice on the left, we have options to manage route tables, internet gateways to allow outbound internet traffic, or egress-only internet gateways for outbound IPv6 traffic, DHCP option sets, elastic IPs, and so on. So the VPC Management Console is essentially one-stop shopping when you need to configure your networking environment in AWS. We briefly mentioned that DNS options are available with the DHCP options set resource. The default is that DNS name resolution is enabled using Amazon-provided DNS servers. That means if, for instance, you deployed virtual machines in a subnet, in a VPC, They will be able to resolve internet names to IP addresses. If you want to, you can specify your own custom DNS server entries that should be used. So DNS servers under your control. For that, you need to create a new DHCP option set for the VPC. Now, what's also enabled by default are DNS host names for your VPC resources. So this would map or resolve to the private IP address of, for example, an EC2 instance. So you can manage VPCs and related resources using the GUI, using the console, but also using the CLI. For example, we can create a VPC using AWS EC2 create VPC. And in this case, the IPv4 CIDR block is being added. You can also create tags using AWS EC2 create tags by specifying a VPC ID and then specifying the tag key and value pairs. You could also run AWS EC2 describe VPCs to get lists of them. You can create subnets with AWS EC2 create subnet. Of course, you would tie it to a VPC's ID and then specify a CIDR block. Within the VPC range, notice at the very top, our VPC CIDR block is 12.0.0.0/16. So 16 bits in the mask means the first two numbers, 12.0, identify the network. So our subnet ranges within that VPC then need to fall within 12.0. So down below, we have 12.0.1.0/24, which falls within that range. That's a valid range for the subnet. The last statement here for the CLI is AWS EC2 modify-subnet-attribute. All we're doing here is turning on the enable public IP addresses by default when resources are deployed into this subnet. At the PowerShell level, we can create a new VPC with new -EC2 VPC. Naturally, you need to specify the CIDR block. We can get a list of them with get-EC2 VPC. We can use new-EC2 tag to add tag items, like to add a name to a VPC. In this case, we're using a hash table after -tag. That means that we have an @ symbol, and within the opening and curly braces, we have the key and value pairs, where the key is separated from its value with a semicolon. And you can have more than just one. We can also create subnets with new-EC2 subnet and then also tag them. So we have numerous ways then to create and manage our AWS network resources.